Hello, am I audible, right? Yes. So let us start this session. In this particular session, let's review the questions. The answers which I've given you for the questions. One second. First of all, let me open the form. So, have you all written the test? Any doubts or any queries in the test you're having? Okay, we will see. We will see the answers and we will discuss. And if you're having any doubts, that will also be clarified over here. One second. Let me share the screen also. So this is the form which I was talking about, where I think day before yesterday, right? We have written, I've conducted this particular test. Yes. So let's discuss the answers for this particular questions. Okay. And I will also enable this particular responses so that you can refer to this answers or the questions if you want. Okay. One second. Let me also have the PPT open. Yeah. So what is the first question? So we are going to have a particular series of multiplexers. We have two multiplexers over here. Okay. Okay. So let us try to solve it. uh, the output of this particular multiplexer is C complement into 0, which will be equal to 0, plus C into B. So F1 is equal to BC. I'm going to get. Let me change the pen color also. So output of F1 is basically B into C. This is my first multiplexer output because if you have the Shannon's expression C complement into 0 plus C into B, which is nothing but B into C. F1 is equal to B into C. We are going to get. And what about this F? F is nothing but A complement into F1 plus F1 complement into 1. So let me write down F2. F2 is equal to F1 complement into 1. F1 complement into 1 plus F1 into A complement. This is what we are going to have in the case of my F1. And if I am going to have this, which is F1 complement plus F1 into A complement, where this will cancel out with each other, and I'm going to have F1 plus F1 complement will be equal to 1, and I'm left with F1 complement plus A complement, which is nothing but A complement plus BC complement, which is nothing but A complement plus B complement C plus C complement, which is which is nothing but A B C the whole bar, which is nothing but a NAND gate. Yeah, so I'm getting NAND gate over here. Is there any answer as NAND gate? Yes, we have an answer as NAND gate. Let me cross verify whether the answer is correct or not. Yes, NAND is correct. Is it clear? Any doubts or any queries in this particular question? Is this particular question clear? Everyone has got this particular answer? Okay. I will also enable this particular form so that you can check the questions parallelly with me. I've already shared this particular form link in the group. You can once check it out. You can open it now. Now, next, let's see the second question where we have three multiplexers over here and we need to find out the function for Z1. We need to find out the function for Z1. So first of all, I'm going to find out the function for Z0. Z0 is equal to B complement A complement. So let me write down the equation for Z0. Z0 is equal to A complement into B complement plus I'm going to have A complement into B complement plus A into B plus A into B, which is nothing but A XNOR with B. This is nothing but my Z0. And coming to Z1, so they are asking Z1 only, right? So Z1, which is equal to, I'm going to have Z0 into C complement plus Z0 into C, which is nothing but Z0 XOR with C. which is nothing but A XOR with B XOR with, sorry, XNOR with C. This is my Z1. This is what I'm going to get. So Z1 is equal to A XNOR with B XNOR with C. Option C. So let us check it out. Option D. I think this option is wrong. Okay, I got few messages also, like you're getting AX nor BX nor C. I think I have kept the wrong option. Let me change it. Yes, it's option C only. Okay. So any doubts in this particular question? I think someone has texted me also regarding this question. So you can see it over here. It is option C only. It's not option D. Okay. Yeah. Now let's move to the next question. So option C. Now, next is a mux shown below is a 4 cross 1 multiplexer. The output Z is. So here they have given something and they are asking what is the output Z. So here plus 5 volts is nothing but you're going to take uh, it as logical 1. Okay, that means I2, I1, I0 are connected to logical 1 and I3 is connected to C. So what is the equation which we are going to get over here? My output Y will be equal to AB into I3. So here, this notations are also very important. I3 we are going to have. Okay, so A into B into I3, which is nothing but C, plus A B bar into 1, plus A bar B into 1, plus A bar B bar into 1. This is what we are going to have. So here my Y will be equal to, if I take common A complement, then B plus B complement will be equal to 1. I'm left with A complement over here plus AB complement plus ABC I'm going to have. Okay. And I can add this two terms so that A plus A complement will be equal to 1. I will be left with A plus B complement. So Y will be equal to A complement plus B complement plus ABC. I can add these two terms so that A will be eliminated. I will be left with BC plus B complement plus A complement. And if I'm going to add this two terms, I will be left with B complement plus C. So Y will be equal to A complement plus B complement plus C. This is my final answer. Yes. So do we have any option like that? A complement plus B complement plus C. Option D. Yes. It's option D. Yes. Any doubts over here? And I've also enabled this particular form. If you want to check it or if you want to write down the test now, you can write it down. Yes. Now coming to the next question. So we have a multiplexer given and they are asking to find out what is the equation for Z. And if you have observed over here, my S1 is connected to 0. Select line S1 is connected to 0 and we are going to have S0 connected to Y. We need to find out what is the output Z. Okay. And what we can do, again, I can take the Shannon's expression. So here I'm going to have the Shannon's expression written S1 complement into S0 complement into I0 plus S1 bar S0 into I1 plus S1 S0 into I2 plus S1 S0 into I3 I'm going to have. And I can see S1 is connected to 0. Okay, so which term will be eliminated? This term will be eliminated and this term will be eliminated because S1 is connected to 0. So you have only this term and this term left out. So here you are going to have S0 complement into I0 plus S0 into I1. Okay. Now what is S0 connected with? S0 is connected with Y. So I'm going to have Y complement into what is I0? I0 is X, XY bar plus Y into I1 is connected to 1. So which is nothing but Y plus Y bar is 1. I'm left out with X. Okay. Yes. So my final answer will be simply X. Okay. We don't have X. Sorry. We have X plus Y. So our final answer is x plus y, which is option A. Once cross verified. Yes, option. Okay. Any doubts over here? Okay, fine. Now moving to next question. So we have a Boolean function realized by the following circuit, and they're asking what is a function f. Yeah, this is also the similar kind of question. You need to come up with a Boolean expression, and you need to solve it uh, using the Shannon's expression. You can solve it. So first of all, with zeroth pin is connected with D, and first pin is connected with C nor with D, and second pin is connected with C dot with D, and the fourth pin is connected with 1. So you're going to get some kind of expression for f, and if it is not in canonical form of representation, you need to convert it into canonical form of representation, and you need to solve it. Okay, then only you're going to get your minterms. So by getting your normal equation, you're not going to get your minterms. You need to first of all convert it into canonical form of expression, then only you're going to get your minterms. Okay. Yes. So the answer for this is, I hope you have already seen the answer. This is a very simple question. You can try it out if you want. One second, let me show you the answer also. For this, the answer is A, which is 1, 3, 7, 8, 12, 13, 14, 15. Just evaluate the expression, just evaluate the logic expressions which you are going to have, and write down the equation. And you can, if it is not in if it is not in canonical form, you need to convert it into canonical form for getting your midterms. Okay. Now coming to this one, the mux shown below 4 cross 1 multiplexer, the output Z is. So again, you need to expand this so that you are going to get the equation. I3, I2 are connected with C complement, and I1, I0 are connected with C. So let us write down the equation. So A complement, B complement into these two are connected with C, into C plus A bar B into C plus AB bar into C bar plus AB into C bar. You are going to get. Now, can we take anything as common over here? Uh, so I can take A bar C common over here, so that it is going to convert as A bar C into B plus B bar plus, and what I can take common over here, A C bar I can take, so that B plus B bar will become 1. A C bar into B plus B bar will become 1. So we are left with A bar C plus A C bar, which is nothing but AX or with C. This is my final answer for this particular question. Okay. So which is nothing but AX or C is option E. Yes. Once let's check it out. AX or with C. Yes, exactly. Okay. Now, now we have a kind of circuit which has been given, and we need to find out the output F. We need to find out. So this is also the same kind of question. I don't think anything. uh, we need to just evaluate the all the expressions. That's it. Okay. So we need to find out f. So first of all, we need to find out the equation of this first multiplexer, and we need to find out the equation of the second multiplexer. And that equations are given to the pins, and we need to evaluate them. But here the tip you can follow, or the trick you can follow, is whatever the expression you're going to get it from the first multiplexer, you can consider it as some m or n. And whatever the expression you're going to get it from the second multiplexer, you can take it as some variable, single variable, so that when you are solving this multiplexer equation, it will be easier for solving purpose. And if you are going to take longer equations, it will be difficult to solve it. So you can take a single expression and you can solve it. Yeah, this is a good question. So the 4 to 1 multiplexer shown below implements the Boolean expression f of w x y z. They have given some minterms. They are asking what is the input. So they have given the output is this minterms. Output is having this minterms. What is the input, so that we are going to get this particular outputs? And the inputs they are asking for specifically is I1 and I3. Anyone wants to answer this question? What is the approach you have used for solving this question? What is the approach you have used for solving this question? Anyone has solved this question? No one has solved? Okay, you can use K-map and you can, okay, that is also a good approach. Next, others, anyone wants to answer how we have solved this question if you have done? Okay, the simple method is you need to write down the equations of this particular output equation and you can correlate with the Shannon's expression. Okay, then you will get what is the inputs which are present over here. That's it. Okay, or else you can use a k-map. Just expand all these particular min terms which you are going to have, and from that just cancel out what are the terms, or if you are going to have anything common you can take them common, and you're going to get the inputs which are connected to input I1 and I3. So let me write it down over here. So have the min terms as 4 5 7 8 10 and 12 15. So first I'm going to expand in terms of wxyz. So I'm going to have W, X, Y, Z, where W is my MSB and Z is my LSB. So 4 is nothing but W complement X, W bar, X, Y bar, Z bar plus W bar X, Y bar, Z plus W bar X, Y, Z plus 8 is nothing but W, X bar, Y bar, Z bar plus 10 is nothing but 8 plus 2, and 12 is 8 plus 4, and 15 is wxyz. This is the equation I'm going to have. Let me once cross verify it. So this is 4, 8, 4, 2, 1, and this is 4 plus 1, 5. This is 7, and this is 8. This is 9, and this is 10, and this is 15. Yes. Now, so you can see over here, W and X are your select lines. So you can group W and X. So W bar X you have common over here. W bar X is common, W bar X is common, and W bar X is common over here. Yes. So you can write down all the expressions Y bar Z bar plus Y bar Z plus YZ, and what else you have? Yes, that's it. Plus you can take W complement X common. Okay, W complement X we have already taken. Take WX bar common. WX bar is present over here and here, which is YZ bar plus Y bar Z bar. Okay. And we have WX left out. WX Y bar Z bar plus YZ. That's it. Okay. And what else we have? We need to get I1 and I3. So I3 will be getting from here, which is Y XOR with Z. Y XOR with Z, because the equation of your multiplexer, which is W bar X bar into I0 plus W bar X into I1 plus WX bar into I2 plus WX into I3, where WX is your select line and this is your I3, which is nothing but Y XOR with Z. And here also we have Y XOR with Z. So we need to cross verify between option C and option D. That means we need to check for I1. I1 is present over here. So we need to solve this equation, which is if we take Z common over here, Y will be cancelled out. So Z plus, let me write down over here, W bar X into Y bar Z bar plus plus YZ. So it is W bar X. If I take Z common, Y plus Y bar will be equal to 1. Z plus Y bar Z bar, which is nothing but Y bar plus Z I'm going to get. Y bar plus Z. Yes, it's option C. Did you get the same thing, Gopal? Did you get option C? Okay. Now, next is the logic circuit shown below implements this particular thing. So, okay, here also the same thing we are going to do where this is going to have W3 as a select line, and we need to get the equations from this too, and we need to get the equation for F. This is also the same kind of question, just evaluation. So all these questions need just a bit of evaluation, you will get it. So W3 is my select line, W3. And first let's solve this equation, which is W2 complement. Let's take it as F1. F1 which is equal to W2 complement plus W2 into 0 plus W2, which is nothing but W2. So F1 is equal to W2. And let's solve for F2. F2 is W2 complement plus W2 W1. W2 complement plus W2 into W1, which is nothing but W2 plus W1, which is nothing but my F2. Now, if I want to find F, which is nothing but, let's say, W3 complement into, let's say, this is F1 plus W3 into F2. Yeah, I need to solve for this. So W3 complement into F1 is nothing but W2 plus W3 into W2 plus W1. And this is W3 complement plus W3 complement into W2 plus W3 W2 plus W3 W1. Okay. So if I take W2 common over here, W3 will be cancelled out. So W2 plus W3 W1 is the answer which I'm going to get over here. W2 plus W3 W1. Okay, I have different answers over here. W2 plus W3 W1. I think we something we have made wrong over here. Okay, others, have you tried? I used came up but got option B. Okay, for previous question you got option B. Okay, once check it out. It's option C. Okay, is it options B? Y bar Z bar plus Z plus Y bar Z bar. Okay. In option B we have Y bar plus Z. Okay. And we need to check for this one. Okay, sorry. Yeah, it's YX not C now. YX or with Z. Yeah, it's option B only. Fine. You're correct only though. And this question, here they haven't mentioned any. Okay, are we missing anything? W3 is my com. I'm getting different answer. I'm not getting any XOR term. 1 second, let me check it out. W3 complement into F1. F1 is W2 complement plus which is W2. W3 complement into W2 plus W3 into W2 plus W3 into W1. This is W2 complement plus W2 W1, which if we solve it further, uh, okay, sorry, it is W2 complement plus W1. Yeah, here we missed it. So it will be W2 complement. Yeah. So this will be W3 XOR with W2 plus W3 W1. This is our answer. Yeah. Which is, do we have some kind of answer like that? W3 W1. W1 W3 We got XOR term W3 XOR with W2, W1 into W3. Okay, once I will cross verify this question whether we are going to have this term or not. Yeah. Okay. So apart from this, any doubts or any queries you're having? You need me to check for F2? Yeah, I've checked it and I've cross verified it. It's W2 bar plus W2 W1, which is nothing but W2 bar plus W1. That is what I have written. And I'm getting W3 bar into W2 plus W3 W2 complement plus W3 W1, which is nothing but W3 XOR with W2 plus W3 W1. This is what I'm getting. Okay, once I will check the question and once I will verify what is exactly wrong over there. Yes. So that's about the questions related to multiplexer. Like we have started with discussion of higher order multiplexer with lower order multiplexer, and also we have discussed different kind of higher order implementations using lower order multiplexers, and also these questions where we are going to evaluate the logics, and also we have discussed about implementation of all the logic gates using multiplexers. Yes. So I think we are good to start with demultiplexers, and in demultiplexers also we are going to refer to lot of questions like this, and we are going to complete the discussion of demultiplexers. Yes. So that's about this particular session. Once I will cross verify the last question, whether we are doing anything wrong or whether the question is wrong or what is exactly there. I will check it out and I will come back. Okay. Yes. So that's about this particular session. If you have any doubts or any other queries you are having, you can let me know, or else we can wrap up this session. Okay. Thank you.